Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, I know that in these lockdown holidays, you have enjoyed a lot with lot of entertainment activities, right? Yes, and even you had given rest to your mind for some time from school education. Now it is a time to coming back to school education to enhance our knowledge. Therefore, our Pi Academy is going to conduct tuition classes from today. From our academy, we will teach two subjects. One is mathematics and second one is science. Dear students, today we shall focus on 10th standard mathematics. Okay, now listen to me carefully. In 10th standard mathematics, do you know how many chapters are there? Yes, you are right. There are 15 chapters. Do you know what are these chapters? Yes, let me go for telling you one by one. Before that, and I give you one more information that when I'll be telling the names of these 15 chapters, you have to identify the chapters which you had already learned in your previous classes, and those chapters will be continued in this academic year. Okay, let us go for the names of these chapters. The very first one is real numbers, second one polynomials, third one pair of linear equations in two variables, fourth one quadratic equations, fifth one it is arithmetic progressions, sixth one triangles, seventh one coordinate geometry, eighth one introduction to trigonometry, ninth one some applications of trigonometry, 10th one circles, 11th one constructions, 12th one areas related to circles, 13th one surface areas and volumes, 14th one statistics, and 15th chapter is one of the important chapter which you have learnt in your previous classes also. This is probability. So these are the 15 chapters which you are going to learn in this academic year. Do you agree with my statement that some chapters are continued in this academic year? Yes. Okay. Dear students, and one more thing I can tell you that this year you find it very easier to learn mathematics because many chapters are continued. Okay. Now let us go for begin the class with the first chapter. It is real numbers. Before that, you have to take a notebook and just follow my instructions. In your notebook, this is the first page, that is index is there in this page. Please do follow this. You can stop the video and then you can go for writing like this. And similarly, in the first page, to write the name of every chapter, you have to follow. Please do follow this pattern here. I have written this. Just go through this. I have used 3 rows and I have drawn with pencil, and vertical column is also drawn, and this box is divided into 3 parts. And first part chapter number, second part real numbers, third part the date on which we have started the class. And you can also again stop the video, then go for writing this. Now, okay, now please do concentrate on my explanation. First I go for writing the name of the chapter. This is the chapter number 1. And the name of the chapter is real numbers. If you are writing, stop it, then observe the board. Now, to learn this chapter, it is better to recall some of the basics what you have learned in our previous classes. They are much needed. Dear students, I will give you a situation that assume that you are in the classroom and your teacher will ask you to ask you that how many desks are there, then what you will do? I'll give you another situation. Your teacher will ask you to find how many students are there in the particular class and section. Then what you will do? Then I give you one more work for your total number of staffs in your school, in your school in which you are studying. What you will do? In all these situations, to know how many are there, you will go for counting. Yes, is it not? Yes, you will go for counting. The concept of counting is termed as number. Got it? So, number is a mathematical concept used for counting. Number is a mathematical concept used for counting. I'll go for writing that in the introductory part. You can go for writing with me also. Right. Introduction. In the introduction, I'll go for taking the very first term. It is number. I won't write the definition. Just you have to tell as and when. You have to recall as and when I tell the definition. Number is a mathematical concept used for counting. Then assume that there are 50 students in your classroom. There are around 10 desks are there in your classroom. Here 50 and 10, what I am using? They are numbers. To represent these numbers, we go for using the symbols. Like if it is 50, you can write like this. This is the symbol used to represent 50. Then if 10 desks are there, 10, this is the symbol. These are the symbols used for writing the numbers. Such symbols are called numerals. The symbols used for writing a number are called numerals. And one more thing. To write the numeral 50, I have used some more symbols, 5 and 0. 10, 1 and 0. I'll take one more number. It is 25,378. See that here 2, 5, 3, 7 and 8. All these are the symbols used for writing the numeral 25,378. And these symbols are called, each of these symbols, they are called digits. Do you know how many digits are there in mathematics? Yes, there are 10 digits. Once I tell, the symbols used for writing the numerals are called digits. There are 10 digits in mathematics. Now you stop writing, observe the word. I go for writing the digits. This is the way of writing the digits. Keep observing. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. They are also numbers. If I go for continuing this, 10, 11, 12. Now look at these numbers, and even I go for encircling some of the numbers and identify what are these. 2, 4, 6, 8, 10, 12. When you observe the encircled numbers, immediately you are able to recall that. Yes, what it is? They are all even numbers. So even number, it's a type of number. So now let's move on to type of numbers. Right, side heading. Types of numbers. The very first one is even numbers. Then what is an even number? Even number is a number which is divisible by 2. Any number which is divisible by 2 is called an even number. I won't write the definition, just you have to listen. A number which is divisible by 2 is called an even number. But I'll write some of the examples. Examples are 2, 4, 6, 8, 10, 12 and so on. Now, again I'll go for listing some more numbers. Keep observing. 1, 3, 5, 7. What do you call these numbers? So, are these numbers divisible by 2? No. Then what do you call these numbers? These are odd numbers. What are odd numbers? Right. Odd numbers. The numbers which are not divisible by 2 are called odd numbers. The numbers which are not divisible by 2 are called odd numbers. Examples for odd numbers: 1, 3, 5, 7, 9, 11 and so on. Written. Now, let's move on to third one. Again, first I go for taking the example. Here, I'll write. If you go for writing a number like 6, could you tell the numbers from which 6 can be divided? Yes, it is divisible by 1. 6 is also divisible by 2. 6 is divisible by 3. 6 is divisible by 6 as well. Then what do you call these 1, 2, 3 and 6 with respect to 6? They are called factors. How many factors are there for 6? There are 4 factors. Similarly, how many factors are there for 1? Only 1. For 2, 1 and 2. For 3, 1 and 3. For 4, 1, 2 and 4. 5, 1 and 5. Here, 1 has only 1 factor. 2 has 2 factors. 3 has 2 factors. 4 has 3 factors. 5 has 2 factors only. What do you call a number which has 2 factors only? And observe these factors. The factors are 1 and the number itself. 1 and the number itself. 1 and the number itself. What do you call such numbers? Correct. They are prime numbers. Right. Prime numbers, or simply we can call them as primes. Prime numbers. Once I tell the definition, a number which has 2 factors only. A number which has 2 factors only, that is 1 and the number itself, is called a prime number. Examples for prime number. Examples are, it is 2, 3, 5, 7, 9 won't come, 11, 13, 15 won't come, 17 and so on. These are some of the prime numbers. Got it? And some will think that a number which is divisible by 1 and the number itself is called a prime number. No, that is not actual definition. Because if you go for taking 1, see that 1 is divisible by 1 and is also divisible by itself. Then do you say that it has 2 factors? No. It has only one factor. Therefore, it is not a prime number. And go for taking some more numbers which are having the factors more than 2, like 4 and 6. Say 6 has 4 factors and 4 has 3 factors. What do you call such numbers? Such numbers are called composite numbers. Please do remember, the definition is very important. A number which has more than 2 factors is called a composite number. So let me go for writing that. Just copy with me. Right. Fourth one, it is composite number. Definition is a number which has more than 2 factors. A number which has more than 2 factors is called a composite number. Example for composite number. First one, I'll go for taking. This is 4, then 6, 8, 9, 10, 12, 14, 15, 16, 18 and so on. Did you observe? Okay, now look at them. Go through again the composite numbers. Here 4. 4 is called the least composite number. And what about 2? 2 is called the least prime number. Then what about 1? 1 is neither prime nor composite. Got it? Let's move on to one more term. Fifth one. Stop writing and look at the board. Here, I'll go for taking a pair of numbers like 2 and 3. They may be consecutive. 2 and 5. But these are not consecutive. Means they are not continuous. Here I have taken a pair of numbers 2 and 3. Are these two numbers divisible by any number except 1? Not at all possible. So these two are divisible by 1 only. What about these two? These two are also divisible by 1 only. Then what do you call such a pair of numbers? They are called co-primes. Please write down. This is also very important. Co-primes. A pair of numbers. Written now you listen to me. A pair of numbers which are divisible by 1 only. A pair of numbers divisible by 1 only are called co-primes. Examples for co-primes. It is, you may go for taking 2 and 5, 7 and 10, 11 and 12 and so on. These are co-primes. Written up. Okay. Now other than these numbers, that is even, odd, prime, composite and co-primes, we have some other different types of numbers which we have already learnt in 9th standard. Let us go for writing them also. Write down, side reading. Some other different types of numbers. Some other different types of numbers. The first one. As and when I go for writing, you should also copy with me. Now listen to me. In the very beginning of this chapter, we have come to know the concept called counting. If you go for counting, then could you tell from which number you start counting? Yes, from 1. Like 1, 2, 3 and so on. these numbers are counting numbers. What do you call the counting numbers in mathematics? They are called natural numbers. Very good. Write it. Natural numbers. Once I tell the definition, the counting numbers are called natural numbers. The counting numbers are called natural numbers. Example, go on writing with me. 1, 2, 3, 4, 5, 6 and so on. They are all natural numbers. If they are enclosed with a pair of flower brackets like this, then we call it as collection of natural numbers or set of natural numbers. And this set of natural numbers is denoted by the symbol called capital N. Understood? Okay. Now let's go on to second one. Second one. Now don't write. Observe the board. Here 1, 2, 3, 4, 5 and so on. What do you call these numbers? They are all natural numbers. I go for including one of the Indian contribution to the field of mathematics. It is 0. Now here natural numbers are there including 0. What do you call this collection? And this collection is known as collection of whole numbers. Let me tell you the definition. The natural numbers including 0 are called whole numbers. Right? W-H-O-L-E, whole numbers. Let me tell you the definition. The natural numbers including 0 are called whole numbers. And write the examples. These are the examples. Example 0, 1, 2, 3, 4, 5 and so on. And look at the board. Here 1, 2, 3 are whole numbers. These are also there in natural number set. Hence we can say that all natural numbers are whole numbers. But the reverse of this statement is not correct. That is, you cannot say that all whole numbers are natural numbers, because 0 is not a natural number. Now, third one. Again, stop writing. Look at it. Here, I'll write 1, 2, 3, 4 and so on. What are these? These are all natural numbers, including 0, whole numbers. Their negatives including their negatives, then all these together called integers. Right? Integers. The whole numbers including their negatives are called integers. Or you can also define like this. Natural numbers and their negatives including 0 are called integers. Written up. Integers, collection of integers is denoted by the symbol capital I or capital Z. In the last year itself we have come to know how the letter Z has been taken. It has been taken from the German word called Zahlen. Z-A-H-L-E-N. Collection of whole numbers is denoted by the symbol W. Written up? Okay, nice. Now observe. Fourth one. And before that, look here. Here, the collection of integers, it includes natural numbers, it includes whole numbers. Then can we say that all natural numbers and and whole numbers are integers? Yes, this statement is correct. Now, I go for taking examples for some numbers. Okay, here I'll write 10. Can it be written in the form of fraction? Certainly. How? 10 can be written as 10 by 1. 10 can be written as 20 by 2. 10 can be written as minus 50 by minus 5. See that? They are expressed in fraction, and observe the numerator and denominator. There are integers. So any number which can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0, is called what it is? Is called a rational number. Once I tell the definition, a number which can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0, is called a rational number. Right? For this you must write the definition with me. Rational number. A number which can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0, is called a rational number. Written, a number which can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0, is called a rational number. Now listen to me. Stop writing and look at them. Here 1 by 2, minus 3 by 7, minus 15 by 6, all these are some examples for rational numbers. Even 0 is also a rational number because 0 can be written as 0 by 1. Then 2 is a rational number. 2 can also be written in the form of P by Q. Likewise, minus 15 and so on. All these are rational numbers. Look at the board. Here, it includes natural number, whole numbers, integers. Hence, we can say that all natural numbers, whole numbers and integers are rational numbers. Understood? And one more thing you had learnt in your previous class with respect to rational number. Just I go for making you to recall that. Observe here. 0.125. Do you remember this? This is the value of 1 by 8. So here it is the number, it is expressed in decimal form. And even I go for taking one more value, that is 22 by 7. What is the value of 22 by 7? It is 3.142857. 142857. 142857 and so on. And this can also be written as 3.142857. Over that you can put bar, that indicates repeated or recurring. Here we have the number whose decimal expansion is terminating, means there are countable number of digits are there. Countable number of digits are there, so it is terminating. Whereas this is What about this? Is it terminating? No, it is not terminating. Continuously it is moving. But recurring part is there. So such numbers are also called rational numbers. So it has another definition, that is a number whose decimal expansion is terminating. A number whose decimal expansion is terminating or non-terminating recurring. Non-terminating recurring is called rational number. Hence, we shall go for writing another definition for this. Write down with me. Right. A number whose decimal expansion is terminating or non-terminating recurring. A number whose decimal expansion is terminating or non-terminating recurring is called a rational number. And the examples for rational number, you can just go for taking these. Example 0, 2, 1 by 2, minus 3 by 7, minus 15 by 6, minus 15, alright, 0.125, then 11.15, 3.142857 bar, etc. All these are examples for rational number. Number which can be expressed in the form of P by Q with the condition P and Q are integers and Q is not equal to 0. Or a number whose decimal expansion is terminating or non-terminating recurring. That is called a rational number. Now, let's move on to another one, fifth one. There are some numbers which cannot be expressed in the form of P by Q with this condition. That is, P and Q are integers and Q is not equal to 0. Such numbers are called irrational numbers. Right? Irrational numbers. Once I repeat, a number which cannot be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. Right. A number which cannot be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0 is called an irrational number. And the collection of irrational number is denoted by the symbol Q dash. And even here I did not write, just go for writing, copy this. Rational number is denoted by the symbol Q. You know that reason. The letter Q has been taken from the word called quotient. Quotient means when you go for dividing a term by another term, you will get quotient. That is why rational number is denoted by Q. And another important point is, in the definition of rational number you have come across, Q is not equal to 0. What may happen if Q becomes 0? Suppose I will write 7 by 0. See that? Do you say that it is rational number? No. 7 by 0, it has no definite value. It is indefinite value. And it is considered as infinity. Now come across again. Irrational number. A number which cannot be expressed in the form of p by q, where p and q are integers and q is not equal to 0, is called an irrational number. I'll go for taking some more numbers. Don't copy, just keep observing. Here, last year you had learned to write some numbers in a particular form, like 5.10, 100, 100, 1 4 times 0, and so on. It's the value of a particular number. Similarly, if I go for taking another one, 10.123, 1233, 12333, and so on. See that? It is a decimal number. Does it have any end? No, it is non-terminating. Is any part of the decimal number repeats? No. So it is non-repeating, nothing but non-recurring. A number whose decimal expansion is non-terminating, non-repeating is called an irrational number. Once I repeat, a number whose decimal expansion is non-terminating, non-repeating is called an irrational number. So write another definition for irrational number. Here I write. Go on copying with me. A number whose decimal expansion is non-terminating, non-recurring is called an irrational number. Okay. Let us go for taking some of the examples. Here, just recall the definition. A number which cannot be expressed in the form of p by q, like root 2, root 3, root 5, root 6, 2 root 7, minus 5 root 3, and so on. They are all irrationals. And decimal expansion, you can take some of them as I have given. 3.10, 100, 100, 100, 1 4 times 0, and so on. Then another one, 6.123, 1233, 12333, and so on. Copy? Okay. Now let's move on to sixth one. Hold on. Observe it. I'll go for taking some of the numbers. Here 1, 2, 3. What are these? These are natural numbers, including 0. Whole numbers. If you go for taking -1, -2, -3, and so on, they are all integers. If you go for taking the number which can be expressed in the form of p by q, 3 by 4, -11 by 3, and so on. Now you can say that rational numbers. If I write root 2, -3 by 5, root 7, they are irrational numbers. See that? Here we have written both rationals and irrational. All rational and irrationals together called the name of the chapter. What it is? Real numbers. Real numbers may be natural, whole number, integers, rationals or irrationals. Right. Real numbers. Real numbers or rationals and irrationals together called real numbers. All rational and irrationals together called real numbers. You may go for taking the examples. See, -3, -2, -1, 0, 1, 2, 3 and so on. Like this. Even 3 by 4, -11 by 3, root 2, -3 by 5, root 7. These are some examples for real numbers. When you come across the decimal number, in case of real number, the decimal expansion of a number may be terminating or non-terminating recurring or non-terminating non-recurring. I'll rub this. Now let's move on to the next part of this chapter. It is also very simple one. You are very familiar with divisibility. Divisibility. Observe this. I go for taking one example. That is, in this example, you are going to divide 30 by 7. You know that method of division? This is 30. Let us go for dividing it by 7. 7 how much are? You can go for taking 7 4s are 28. Then what is the difference? Difference is 2. And subtracting 28 in 30, you get 2. And you are also very familiar with the terms that are involved in this division. Then what do you call 30? 30, it is dividend. The number which is to be divided is called dividend. What is this is? 7 is the number which divides the dividend. It is called what it is? Got it? It is divisor. Then after dividing, you will get a number. This number is called quotient. And at last, you get a remaining part, that is 2. And this part is called remainder. Not a reminder. It is the remaining thing, it is remainder. So these are the terms that are involved in the divisibility. Dividend, divisor, quotient and remainder. And to check that whether our division is correct or not, we have a statement. Can you tell that statement? See that here, go for multiplying 7 with 4. 7 4s are 28. 28 plus 2. 30. Hence, can we write 30 as 7 into 4 plus 2? Yes. 7 4s are 28. 28 plus 2, 30. Hence, we can write a general statement as, what is 30? 30 is dividend. 7 is divisor. 4 is quotient plus remainder. 2 is remainder. Now you just go for writing quickly, as quick as possible. 30 divided by 7. Then go for dividing it. 7 4s are 28. Then difference will be 2. Then go for writing all the terms. 30 is dividend, 7 is divisor, 4 is quotient, and 2 is remainder. Then you write 30 is equal to 7 into 4 plus 2. Then dividend is equal to divisor into quotient plus remainder. Written up. Okay. If not possible to write quickly, then you can do one thing. Just stop the video there and go for copying. Then immediately again you can come back. So far what we have learned up to here, this is the basic related to the chapter real numbers. These are the basics. First we got number, we have got the definition of numbers, numerals, digits. Then types of numbers, even number, odd number, composite number, then co-primes. Then after that, different types of numbers, natural numbers, whole numbers, integers, rationals, irrationals, reals. Now another important concept, it is divisibility. Okay, now listen to me. Now we are moving to the actual part of this chapter. In this chapter, we are going to learn two important properties of positive integers. Do you know what are these? Let me tell you that. The important properties of positive integers are, one is, it is Euclid's division algorithm, and second one is fundamental theorem of arithmetic. These are the two important properties of positive integers. In this chapter, we will also go for stating these two along with their applications. Right on, side heading. Properties of positive integers. Properties of positive integers. This first one is Euclid's division algorithm. Euclid's division algorithm, and in short you can write it as, its abbreviated form as EDA. Second one, fundamental theorem of arithmetic. Fundamental theorem of arithmetic, and you can write its abbreviated form as FDA. Written up. Okay, now just look at the book. So, right, it's an abbreviated form FDA. And before going to that, what are these? Euclid's division algorithm and fundamental theorem of arithmetic. Let us focus on some of the terms like algorithm. Right on, side it. Algorithm. What is an algorithm? If you go, we come across, in mathematics we come across different types of problems and different methods from which we can solve those also. But in some particular cases, we will go for following the particular steps only. If it is first step, next we have to move on to the second step, then soon after that third step. So here you cannot skip. Just let us go for taking one of the example, that is, consider a statement which can be proved logically. It is a theorem. While proving a theorem, we go for following some steps, like the first one is drawing appropriate geometrical figure. Second one is writing the given information is nothing but data. Third one is to prove. Fourth one is construction if necessary. Fifth one is proof. And last one is conclusion. Now, do you think that can we go for shuffling these steps? It is impossible. These are the particular steps to be followed to prove any theorem. Likewise, in arithmetic part also, we have some of the problems where we use the particular steps. So that a series of well-defined steps which can be used for solving a particular type of problem is called algorithm. Once I repeat, a series of well-defined steps which can be used for solving a particular type of problem is called algorithm. Algorithm, it is a word taken from a name of Persian mathematician. He is Al-Khwarizmi. What is his name? Al-Khwarizmi. I'll write that. Before that, go for writing the definition of algorithm. Algorithm is, a series of well-defined steps which are used to solve a particular type of problem. Is called algorithm. As I told you, the word algorithm has been taken from a name of a Persian mathematician is Al-Khwarizmi. Right? Algorithm. Mathematician name is Al-Khwarizmi. Al-Khwarizmi. Now, even you might have heard one more word, that is algebra. The word algebra has come from the book written by Al-Khwarizmi. Who is he? Sorry. The name of the book is Hisab al-Jabr wa al-Muqabala. Hisab al-Jabr wa al-Muqabala is the name of the book written by Al-Khwarizmi, from which the word algebra has been derived. Right? Hisab al-Jabr wa al-Muqabala. Hisab al-Jabr wa al-Muqabala. This is the book written by Al-Khwarizmi, from which we have taken the word algebra. Over. Okay. Now, so before going to stop the class, let me tell you one thing. Today, what are the things we have learned? Just to go for recalling them. These are the basic information with respect to this chapter. And in the next class, we shall go for continuing this concept. Particularly, we focus on Euclid's division algorithm and fundamental theorem of arithmetic. Thank you.